explore finding the domain of a composite function. First, let's give the definition of the domain of a composite function, which we have not yet done. The domain of f circle G is, let's think about this for a minute. This is the function that takes in x and outputs f of g of x. So for the domain, what we'll use is all the values of x for which this is defined, f of g of x. Let's think about this this way. How do we end up with f of g of x? To get to here, we need two things to happen. We need to first be able to evaluate g at x. So x must be in the domain of g. And for g of x, we must be able to evaluate f at g of x. So g of x needs to be in the domain of f. And we see that as long as those happen, in fact, that f of g of x will be defined. Let's do an example. Here, f is the function defined by the formula x over x plus 5, and g is the function defined by the formula 1 over x minus 2. Let's find the domain of f circle G. So when the two functions are functions given by formulas, here is a convenient way to find the domain. Let's first come up with the formula of the composition. So I take the formula for f and replace x by g of x. Okay. So here's the formula before we do any simplifications. Well, let's see what we get when we simplify completely. One over 5x minus 9. So we see that 2 is defined in this formula. This formula down here. But 2 is not in the domain of the composition, because 2 is not in the domain of g, the inside function. So there's a difference here between the fully simplified formula and this formula you get before you do any simplifications. Let's take a look at this formula that's circled in red. We can use this to see what we need to exclude from the domain. Where is this formula not defined? The formula circled in red. Well, it's not defined whenever we have a value of x that makes some denominator 0, and it's not defined at any value of x that makes some radicand equal to a negative number. We're taking an even index root, like the square root of minus 1 or the fourth root of minus 5, etc. So the only thing we have to worry about here, based upon the formula, is where the denominator will equal 0. And we see that at x equals 2, some denominator will be 0. In fact, both of the inside denominators will be 0 there. Okay, what about the outside denominator? Is this ever equal to 0? Let's solve this equation. We get the solution x equals 9/5. This does make this outside denominator 0, and so we now know what to exclude. The domain is a set of all x's such that x is neither 9/5 nor 2. Again, use the formula before any simplifications.